Hi, everyone. My name is Kennedy Mason. Thank you so much for being here today. I hope you guys have all enjoyed your time at Domopalooza so far. Up next, we have the session AI Readiness. Is your organization ready for change? With our very own Chief of Design, Chris Willis, and Flo Silveira. Please help me in welcoming them.
All right.
Hi, everyone.
I don't know if you can hear me. I guess mine's not on yet. There we go. So welcome. Thanks everybody for coming out. We're very excited. I heard this was like the most popular signed up breakout, or maybe it was the third, but I'm going to go with first. So if that's okay with you guys, we'll just run with that storyline until someone really challenges us. To get started, I thought, as we talked about in the morning session, it's important to kind of just sort of talk about the moment that we're in, right? You see if this is working. So today, I'm hoping as part of this, you guys could at least walk away with a good understanding of what do I need to know about this moment? What are the things keeping us from taking advantage of it? And Flo is going to do a deep dive on the third point, how to get ready. And then we're going to talk a little bit about what's next and then have some Q&A. So giving you a heads up. So if you guys have, some questions, start thinking about those now because we'd love to take them. I think we're going to take about 10 minutes at the end for questions. Great. So as we were talking about today, it feels like this moment, right? We need more googly eyes, I think, on this one, but everyone's in the AI business all of a sudden, right? And it's not that we haven't been in the AI business before. And Flo will talk a little bit about that. But there's two really strange competing forces at work here. And that's what we're going to be talking about, which is, as I mentioned earlier today, it's actually like 15.7 trillion. I mean, these are all estimates, right? That there's going to be this huge unlock in value. Where's that value going to come from? It's going to come from new business opportunities. It's going to come from optimizing operations, right? It's going to come from new productivity gains. We're not exactly sure, but it's going to be probably infused in everything. The problem, though, as we talked about this morning, most of us are not good at doing the basics of AI. And that's, again, what Flo is going to focus a little bit on is like, how do you know? What do you do next? So as part of understanding what this moment is and like, why are we talking about this now if it's already been around forever? And just as a again, historical context, I guess I'm big into history. In the 1950s, AI, and I think we started with that Buckminster, was that Buckminster? No, it was Arthur C. Clarke, I think is who was in that, right? That video that you saw in the opening. This has been a big idea for a long time. It actually goes way beyond the 50s, right? Like Reverend Bayes and the Bayes theorem went back hundreds of years. It was like 1600s or something like that. But in the 50s, that's when artificial intelligence, the actual term, was coined. And we've been kind of chasing what artificial intelligence means and how to apply it. And so I'm sure a lot of you are familiar with this idea of AI winters, right? AI that never delivered on the promise. So it's always kind of a cliche in some ways that AI is always the thing that it doesn't do, right? It's always the next thing. It's like, it's kind of good at predicting, like winning a game of chess, but it can't write a poem. Well, now it's like good at writing a poem, kind of. With Dan Reynolds on stage today, like he cringes, but if you're not Dan Reynolds, that might actually be a pretty good response, right? But for Dan Reynolds, that's kind of interesting AI, but it's not perfect. It never is, right? It's always something that's kind of moving. But one of the things that's kind of fascinating, again, back to this idea of like the paradigm shift, is people have been working on this for decades. I remember one time I was working, it was a long time ago. I guess it was like in the late 90s, early 2000s, working on like these ensemble AI ideas because no one really knew what was happening. And there was this big kind of interest in something called a neural network. So you can see like when deep learning started, and then it just went away. It was like people's careers were being buried by even talking about this stuff. So that's why I think, you do run into these situations where it can take forever to become an overnight success. But generative AI has really changed the game almost overnight. And we're going to talk a little bit about why that is. I did a lot of research trying to find the latest survey data about how many enterprises are using AI. I wasn't able to do that. I got a few signals, but I think the importance of this up to 2022 is you can see we kind of plateaued. And in fact, I remember, I think it was about like a year and a half ago. Um, Someone invited me to come out and speak about AI, and I was like, what do I talk about? Like, it's almost like AI is boring, right? There's nothing really to talk about. But that number where it's around 50 right there, the latest ones I saw were already at like 60 or 70. And so what does that mean? That means that most organizations are actively starting to figure out where they can kind of do enterprise applications or critical applications of AI in their organization. That was not the case. In fact, it was actually fairly startling. Some other surveys showed things like marketing where maybe 5% of their work had some critical AI element to it. I think that's going to change dramatically, right? I mean, I think you saw today just in our videos, there was a lot of like mid-journey imagery showing up, right, from the marketing team. It's already happening. And that kind of thing is changing the way we look at what intelligence is, what artificial intelligence is, and what the opportunities are. So, right here, just I threw up some ideas that you're starting to see in terms of what generative AI can start to do in very broad sense that other AI just couldn't do. In finance and marketing and IT, sales, etc. And I thought it might be useful for you as you're thinking about this, as you're going to some of these other talks, as you're looking at some of the product announcements, and as you're hearing what Flo is talking about, just why this new creature of AI is so different and has so much more potential. And again, we've been through hype cycles before, sure, right? But things aren't going to be perfect. We get that. However, we're already like testing this stuff, right? We've been doing this for like a year. We've been building applications. So far, it holds up pretty well. And I think the reason it holds up is important to understand. So traditional AI, and I'm saying traditional AI is everything that happened before 18 months ago, for the most part. So not the transformer models. And this is important. Those algorithms really just did two things. They predicted things or they classified things. So what should I buy next? What book should I read? What YouTube video should I watch? You did sentiment analysis, right? You did time series prediction. You did all these things. We didn't have something that actually generated content or generated kinds of knowledge. That didn't happen. It always required some specialized interpretation, right? The second thing is, and I'm sure Flo can talk to this a lot because you're probably going to talk about some of these examples. A lot of that AI had to be very specialized, meaning you had to have, a specialized training set, right? It's like, okay, I really want to apply this to my customer sentiment, or maybe I'm doing, like loan or mortgage data, but I have to train it on the data we already have. So we got to train and test and validate, and we're going to keep monitoring it. And sometimes that worked. It was very intensive. It was very expensive. Sometimes it didn't work because your data was very biased in some way, right? And you created a very specialized, but maybe a very biased kind of solution, which is not great. New generative AI can be applied to a lot of things that you didn't tell it or you didn't train it to do in the first place. And that's super fascinating. And it's, there's debates about, whether or not this is an emergent kind of behavior or intelligence. I don't really know. I think that's a bit of a diversion. But what we do know is when you are able to apply sort of a large language model, especially, that's kind of what we're focusing on, it's already learned a lot that you've never know it could learn. Right? So traditional AIs were supervised learning, right? It's what we kind of call supervised learning, meaning you essentially had to give it some form of digital flashcards. Here's a picture of an apple. What do you guess it is? It's a cat. Nope, it's an apple. Okay, correct. Change, do all that stuff. Generative took a while because we had to figure out, and by we, researchers, had to figure out how to do self-supervised learning. So just giving it text. And in a weird way, that's how we learn, right? We learn from just imbibing or consuming lots and lots of information and then trying to understand the context. I'm sure if any of you have small children, you've seen that in action, right? They learn concepts and how they learn language. So what's fascinating is there's a lot of knowledge in there. Some of it's probably not correct, but there's a lot that you can kind of build upon that we just didn't have access to. So that's going to be just a long journey of trying to understand how these sort of black boxes work. And then just 3 more here. At least in my experience, it can be fairly costly to train your traditional models because you have to get the right data. It has to be curated. You have to break it into train, test, validate type sets. But usually once you get it, it's pretty efficient. It's pretty easy to run those things, whether it's like, an XGBoost or, well, linear regression is probably the easiest one. Like, it's pretty straightforward. Generative AI is a little different. One, I think the first model of OpenAI was like $100 million to train. At the start, when we were looking at, like how LLMs were going to evolve, it looked like, and this is about a year ago, it looked like they would become the new moat, right? So Google has their PageRank algorithm, and it's like, good luck. You're not going to have that. It's not the case. What's interesting is, and one of the reasons, you heard in some of our announcements around the AI services layer, will allow you to use any model you want. So, there's 300,000 models on Hugging Face, but when it comes to large language models, they found that you didn't need these huge models, and as such, you don't need as much compute to run them, so they're a lot less costly to run. And they're also less costly to train because you can take some of these smaller models and just fine-tune them on your data or prompt them with your data. So there's a big opportunity there, and that's why we're really digging in on providing a lot of flexibility around those things. And then just 2 more. When it comes to data, and again, Flo's going to talk about this quite a bit, is the data doesn't already have to be in any kind of special form, right? And that's super fascinating because, again, just a few months ago, these kind of things that were sort of impossible. So what do I mean by that? You're looking at a bunch of reviews on your, that customers are writing on your site or on a Yelp page. You didn't have to really train the model to either go through and parse that information and turn into like a JSON file that you can then, ingest into, some other sort of workflow. It's already getting it. However, there are some gotchas. And again, Flo's going to talk about those. And this is a biggie. This is that part where it's like not quite perfect. So you're going to have to learn how to, kind of dance with these dragons. Is traditional AI is well understood for the most part. I would say mostly, there were some deep learning things that maybe, are a bit black boxy, but generative AI, I guess it's a feature more than a bug, in that it has randomness built in. So it's one of the things that makes it interesting. It also is one of the things that throws in quite a question mark, I think. So it's like trust and then verify, I think is sort of a good way of thinking about it. The way we talk about it internally is we think of some of these models as kind of like smart interns. Like, okay, you're very efficient, but you're not super experienced, and some of your questions or the answers to my questions might be somewhat incorrect. So we have to understand that. So of course we're all thinking about that, trying to figure out how we can build in the proper sort of guardrails around those things. But that's the nature of the technology, right? It's not going to kind of disappear. In fact, if anyone's kind of gotten into the weeds on some of these things, you'll know that some of these large language models have something called temperature. There's certain hyperparameters like perplexity, and temperature is how random do you want me to be in my responses? Perplexity is how smart or how verbose you might want me to be in terms of combining, your prompt with everything I could tell you possibly, because I've read everything on the internet. That's an important one. So just a caveat for folks. So what are the things that keep people most, what's the biggest stumbling block? It's clearly data. This is one of those things that I know it sounds kind of like the kale smoothie of talks, right? It's like, oh yeah, I know data's supposed to have proper hygiene, and I got to make sure it has metadata associated with it. But I think as Josh talked about today, the better data, the better the AI. That is just a fact, right? And so the more you can do there, you should be able to get a real cumulative effect. And you can see right here, this is, you wouldn't be alone thinking, that data could be a problem. And then, Josh said he'd been, we've been having some conversations with Snowflake there. And I think Frank, I know now he's the chairman. I think he's stepped down recently, obviously, from CEO. But he had two things. One was get your data estate in order. And the other was, as excited as he is personally about, a lot of these generative, shiny new models, most companies don't really do the normal AI super well. So before I pass it off to Flo, it's not all like negative sort of doom and gloom. There are some real forces out there that you're probably going to be facing. One is going to be, there's going to be productivity, right? Reduce costs, right? Automate things. I think one that's kind of overlooked is a lot of the other applications you're using will probably have AI in there somewhere. So how can you sort of inform yourselves and become a better consumer of other AI products? Because it's not just going to be, using Domo. It's going to be lots of other things. And then, of course, I think, this year, I think 2023 and 24 feels like the year of like the shiny, glossy videos. But in this next year, folks like you are going to start actually using these things and learning and starting to, find some success and probably a lot of frustration. But the competitive pressures are not going to ease up. It's just the nature of this thing. So starting with that, and we'll sort of recap this at the end. The way we would start, and we call this, like sort of our day zero, because it's early days, right? This may not be the strategy you use in a year or two, but right now it's you start simple. Make sure you have very sort of clear security, ethical, and governance guidelines. That's huge, right? Like me personally, I wouldn't put anything really important in a model I didn't understand that wasn't hosted by me. We actually run models like on our laptops a lot for that reason. Suitability is one of the biggest barriers to being successful. And I'm sure Flo can add a little bit about that one, where you don't quite understand the tech well enough, or you don't understand the problem well enough. And the combination of those two things sets you up for failure. Let me go back on that one. Talent and culture, that's a huge one. Oddly enough, in some of the surveys we saw, I think it was a Deloitte survey, which was really baffling. But most companies think, I probably should have asked you this question first, sort of set you up for something, but most companies think they have enough talent, specialized talent in generative AI and other AI applications. But then you look at another survey and most companies say they don't have that talent, or they're concerned that they won't be able to get that talent. So that's definitely going to be one. And then to set it up, again, it comes to getting your data house in order. So with that, I'm going to pass over to Flo, and she's going to talk about the 13 cardinal sins of AI-ready data.
Ooh, it's catchy, huh?
Would you like a laser pointer?
I would like a laser pointer. Thank you. And it works.
It works.
For those of you standing in the back, there's some seats up here if you want to join. I promise to not make too much eye contact or make you feel awkward, but there's a few seats here. So I'm so excited to be here. I'm so happy that you could all join. I hope you're enjoying Domopalooza. As a data scientist at Domo, I am very passionate about data cleanliness, and that may come through in the next 15 minutes or so. So let me tell you a story about grad school. This is me at 3 in the morning working on a project when I was in grad school. And for this project, we were putting together a report for a large international agency that was focused on educational inequality across different countries. And I came in and someone gave me the data set that they had put together, and I put together some cards, visualizations, charts, tables, just to see high-level distributions. I just wanted to understand what was happening with the data. And immediately, I noticed red flags. South America had the most students. Thank you for sitting in the front. You listen.
Brave.
South America had the most students, which I knew as an education expert at the time that wasn't the case. The Dominican Republic had 4 different regions associated with it, and the United States could show up as the US, or the USA, or the United States, or the United States of America. And I dove into this to understand what was happening, and I found that there were issues with joins, right? And I fixed it. And if we hadn't fixed that, the policy recommendations that we would have made to this large international agency would have been flawed. and there would have been real consequences for that. What really stands out to me about this experience is that the program I was using to put together these high-level distributions, that program was never going to tell me that my data was wrong, right? It was never going to say, your numbers for South America look a little too high. You should look into that. I had to provide that subject expertise that really caught the problem. Which brings me to this idea of data cleanliness. So I'm part of Domo's AI Labs team. We're all data scientists. We work with customers. We also do a lot of development. And we all have very different backgrounds. But all of us feel very, very strongly that data cleanliness is really the most important part of any data science machine learning process. We spend a majority of our time prepping the data to feed it into the algorithm, right? And we've worked on a lot of projects, and we've seen the same problems over and over again. And we've packaged all of that, and we're gonna share some of those insights with you today. Things to look out for when you're cleaning up your data, no matter what kind of AI you wanna leverage, right? Data cleanliness is important for all types. Descriptive AI has been around for a long time, as we've talked about, right? This is just analytics and reporting. We've got generative AI, which is the big thing right now, right? LLMs and automated insights. And then what has traditionally been thought of as predictive AI, which includes any sort of prediction and machine learning. Fancy algorithms are not going to fix bad data unless they're trained to do so. And that requires a lot of training, and it's pretty costly. What most of us want to do with generative AI, oopsies, go back. I spoiled the surprise. What most of us want to do with generative AI is to ask questions about our data. Most of us are not looking to build our own LLMs at this point, right? But we want to leverage a chatbot to ask questions, descriptive questions or predictive questions about a data set that we have. But if we feed that chatbot a bad data set, it's gonna give us bad results. We have this saying in our team that garbage in, garbage out, right? If you feed it bad data, the results are gonna be unreliable, even if the chatbot doesn't tell you that the results are bad. So with that, this is the 13 cardinal sins for AI readiness. This is not an exhaustive list of all the things that could be wrong with your data set, but these are some of the most common problems that we see. And I see some of you are taking pictures of this. Don't you worry. We have a data hygiene checklist that will definitely be emailed to you. And it's more detailed, and it has examples, and we absolutely love to talk about any of these things. So come find me after if you have any questions about any of them. And unfortunately, this is not an 8-hour session, so we can't talk about all of them. So we can choose a few with the time that we have. So what do we want to talk about? Anyone can pick. Raise your hand. Yes. Column quality. Yeah, so we've got 3 under that, right? Unclear and or long column names, private and sensitive information, and no engineered features. So let's start with unclear and or long column names. And this really takes me back to grad school because I work with a lot of publicly available data, and their naming conventions are a nightmare. So 2 things that we have in this list, right? Unclear and or long column names. Let's start with long column names. The first column name up there that you see is insanely long, right? Labor force participation rate, female, percent of female population ages 15 and up, national estimate. You do not want to type that every time you want to reference that column. And if you've used R, it's a nightmare to have a long column name because it doesn't handle space as well. So long column names, while helpful and informational, are really not practical from a data pipeline perspective. That kind of information is really useful to have in a column description in Domo, especially if you plan on using generative AI. If you want to ask a chatbot about this particular concept, having the column description be this descriptive would be really helpful. It's just not a column name. And then there's the opposite, right? The TR_14C. I I don't know what that means. I don't think anyone knows what that means, not even the person that put the data set together. There's no way they have 200 columns with that labeling convention and they know what each column represents. So having names that are intuitive is really important. I don't know if TR_14C is sales or units or head count or if it's a count or a string variable. I just have no idea. So having names that are useful is a very, very important component. Private or sensitive information. This is huge, right? Private or sensitive information includes all these components such as addresses, names, dates of birth that can help an individual like me identify a person. We don't want that, right? This type of information is protected by law, and it's very strongly regulated, and you do not want to be in hot water about that. And with the constant evolution of generative AI, we want to make sure that this is not available to anyone who just has access to the data set, right? So making sure that we address private or sensitive information is really important. And it was announced today, Domo is building a universal model for PII, which can identify systematically this type of information in either a data set or in your instance to help you make that process easier of making sure that people have the right access. And the last thing in this section is no engineered features. So here we have an example of start dates and termination dates. And we do a lot of turnover cases in our team. And a model cannot process dates very well. If any of you have tried, it just breaks. The model's not really gonna run. If we wanna predict who's going to churn or what our employee churn is gonna be overall, this is just not helpful for any model. So we need to have some features that can easily be processed by an algorithm, right? So we would want to come up with an engineered feature version of this. We could say, let's calculate the tenure, the difference between the start and the end date. Or instead of having the granularity of the day, maybe we can just roll it up to the month, right? So then we have a larger aggregation to work with. We could even just come up with a flag where they terminated it all or not. But the date component is not something that can easily be manipulated by a model. So let's go back to the table of contents, which is this really long list. And we can pick maybe one more thing, and then we'll show you a few more things in Domo. Which one? Insufficient volume for segmentation. Or how do you avoid the pitfalls of AI? I can speak to insufficient volume of segmentation without the slide. So a lot of the times in data science, we want to segment our data or slice and dice our data in a lot of different ways. So for something like employee churn, we might want to consider the department that they're in. We might want to consider their tenure. We might want to consider their job role. Are they a nurse? And that's actually the example we're going to talk about today. So you need to have, once you've sliced and diced all the ways you want to slice and dice your data, you still need to have enough rows of data to have reliable results, right? So if after segmenting my data by department and by job role and by tenure, I'm down to 2 observations for nurses that have worked there for 3 years, that work in labor and delivery, then I can't run a predictive model on that. I don't have enough data, which would require me to move up and remove one of the segments, right? So I would have to say, okay, well, maybe department doesn't matter as much. I'm gonna focus on the other 2. So having sufficient data is really, really important. Something that we run into a lot because we all start with really, really big data sets. And once we include 10, 15, 20 features in a predictive model, our buckets of data are much smaller. So with that, let me show you a use case that we've done on employee churn. Because again, that's a very popular solution we've got. So I'll switch over to the demo here. Here we go. So I created cards using a raw, completely untouched data set for employee churn, where we didn't do any sort of the data cleanup that, again, takes us about 80% of the data science solution process. The first thing we normally look at is historical turnover, right? What did it look like in the past? And what you see here is that I've been neglecting this side of the room, so I'm coming over here now. What you'll notice is that a majority of our data starts in January of 2022, right? And we've got quite a few observations after that. But we've got all these people down here, some from 2000, someone in 2004, 2005. These are just not in the same category, right? Like, they're very different from the people that we have here. It's very difficult to believe that we didn't have anyone turn over in 20 years. Like, there's just a gap in our sample that we need to address. These are really like outliers in terms of time. And their data is probably very different. If we think about average pay in 2000 as opposed to 2022, we can't just compare those and treat them as the same. So in this example, the sample wasn't defined clearly. Then we look at this segmentation idea, right? How many people who did turn over fall under each of the job role categories? So we've got nurses that make up the majority, doctors, therapists, residents or residency students, and then we've got administrative, and this right here that you can't see is office support. And office support only has 7 observations. If we're starting off with just 7 observations in that group, then we probably can't segment by anything else for that group. I mean, 7 observations is already too small. We probably want to bucket that with administrative. We would, of course, have to do some checks, right? Make sure that they have similar pay, similar tenure patterns, but they could be lumped together so then we're not losing that information along the way. What if we look at average monthly pay? And again, this is the unclean, anonymized data set for this solution that we put together. As you would expect, doctors have the highest average monthly pay, and then somehow resident students have the second highest. That doesn't really check out, right? They're making more than therapists. I don't know. I actually don't know how much nurses normally make. I should know. But like, that just looks funky. And then we have this right here, which is a huge bar for which we don't know the job role. This needs to be addressed too. We need to figure out where they fit. Otherwise, these rows are going to be dropped, because a data science model or a machine learning model is going to drop rows for when it sees missing data. A regression will drop the entire row if one single column is missing the value. So we got to address that. And if we dive a little deeper into this averages situation, we'll see that the residency average is really influenced by one outlier. Someone is probably not making this much money as a resident student, but probably not. There are instances, though, where you may want to keep the outliers because they make sense. So it's all use case dependent. In this scenario, it's likely that that is a typo of some sort. But in some use cases, the outliers just need to be handled differently, not dropped or replaced with a different value. Now, what if we were to do some sort of prediction on this, right? So we've got the original data set forecast, and you'll notice when we look at the history, oopsies, I broke it. Okay, we'll just look at it. Oh, there we go. You'll notice these peaks right here, right? In July, well, June and July. If we didn't dive into our data and look at the different trends for different segments, we probably wouldn't notice that those peaks are actually due to resident students who normally start around July, and they have some sort of agreement, some sort of termination, and it tends to happen in the summer. And those people are very different from the other employees that work at a hospital, right? They tend to know when they'll be gone, and so it doesn't make sense to include them in the same forecast. We would have to do a segmented forecast for that. So if we remove those residency students, our forecast looks a lot cleaner and flatter, right? That seasonality that we saw earlier is not as prevalent. Okay, well, just look at it like that. So if we don't fix the errors before putting it through a fancy algorithm, we're still gonna run into unreliable results. The last thing I wanna show, and I know some of you saw it earlier to some extent, is the chat. And this is so cool. This is leveraging generative AI to answer questions about our data. And I already asked the questions, but imagine that you don't want to build your own visualizations for whatever reason. You just want to type out the questions. Or you have people that are new that don't know how to build visualizations. They can leverage the chatbot to ask questions of the data. So I asked the question, what is the average monthly pay by age? Sort from oldest to youngest. And I get a nice output. I could have asked for a visualization if I wanted to. But this is a really easy way of just interacting with your data. And in this case, the data's bad, right? The data hasn't been cleaned up. But this is a good way to start the data cleanup process. Ask basic questions of your data. See if something looks wrong or if there's a red flag. Because, like I said, we still need humans involved. The checking, the validating of data is a really important step that AI is not doing for us yet. It probably will soon. But at this point, we need to be heavily involved in determining what looks right and what doesn't. I asked other questions, right? How many nurses are currently employed in Arizona? 120. These are the employees who have worked more than 30 years. If you want to do some sort of like loyalty campaign, you could ask this question. So the chatbot, I think, is getting us so close to this data hygiene opportunity that Domo is providing. And I'm excited to see what else it can do in the future. So I'll turn it over to Chris again.
Sure. So Flo, thanks a lot. I think that's a perfect example. I mean, the number of ways data can go wrong is, I guess, basically infinite, right? And so thanks for showing a few here, but I think you're starting to get a flavor for, like, you know, you can go get the latest, shiniest sort of AI. It's not going to really change anything if you have problems like that. And so being able to find those problems, being able to communicate them properly, you know, and also maybe helping people kind of in your organization learn a little bit more. Like, we might need a little new language about how we talk about data. That might be really important. And I don't know how to do this without going through all the slides, but can we get to the last slide?
Or we all sit here for another 4
I'll
hours
sit
and
here,
talk about it all.
But let's do this. So I'd love to open it up to questions. I mean, obviously, I think Flo's probably the most qualified to answer any questions here, so you can just ask her.
No. But we will send you the data hygiene checklist.
That's right.
I hope you're all as excited for it as I am.
Yeah, could you, I'll go back just one slide here. So I want to make sure, just a level set. It's like, you know, why is this a moment, right? What are some of the biggest pitfalls to actually leveraging the opportunities, both economic, productive, you know, capability-wise for AI? And then how do you start getting your data AI ready? I think we've covered those, but, you know, let's ask some questions, or we can start talking about, like, what next. So I'm not going to pick anybody, or should I? No.
Pick anybody. It's kind of hard to see hands, actually, with the lights.
Yeah.
So he's got a question right there.
Maybe we'll also repeat the questions.
Yeah.
So for people who are,
He's got one right there.
yeah.
Okay.
I'm just going to tell you, we're going to repeat your questions. Yeah, go ahead.
I'm curious about the difference between generative AI and evolutionary AI.
And what do you mean by evolutionary AI? Like genetic algorithms?
Yeah, so kind of a Darwinistic. There's an approach that's kind of a Darwinistic approach. So the idea is that you train and have profiles that mutate.
Yeah,
Right.
So it is, sort of takes me back because I think it was like in the late 90s. I'm really dating myself here, but I had the opportunity. I was working in magazines, and I had the opportunity to interview John Holland. So the question is, what's the difference between, or how do you think about evolutionary AI versus new generative AI? And so just a little perspective. John Holland was one of these, like, remarkable people who came up with, well, he had a PhD in computer science. He had a PhD, I think, in evolutionary science. And he combined those two. And I remember going to visit him, and he lived in this kind of sort of Buckminster Fuller type dome house. And at the bottom, there was like this big sort of tube that you would then take a spiral staircase up to. And he had like a Steinway at the bottom. And then he had, when you got up into his like loft area, there was just skeletons of birds and art and everything. So he was a really remarkable guy. But to answer your question, when I think of evolutionary AI, I'm thinking mostly of genetic algorithms. And genetic algorithms have been extremely effective in certain kinds of cases. For those who don't know, the idea behind genetic algorithms are that you're using a certain form of AI that describes the problem in terms of essentially a gene, like a DNA, like a genome. And then what it does is it creates a lot of random different mutations of those genomes. And those genomes are then applied to doing things like trying to create a robot or robotic movement that can then like walk up the stairs or walk or run or whatnot. I think one of the most successful things, at least at the time I remember John being really excited about, was using generative AI to create new kinds of turbine blades for like GE's engines. So I don't know if you ever get up close, you'll see, the old jet engines had very straight kind of blades, and the new ones have these weird sort of wavy sort of shapes to them. The bottom line, though, is it's really hard to describe a problem in that way, and it takes a huge amount of processing power to run all of those simulations, because that's what you had to do. There's still really interesting applications for it. And so, being able to sort of apply the power of evolution to it is great. In a way, the large generative models kind of work that way. In fact, all deep learning models kind of work because they start off with a random state, right? So you might have a deep learning model that has, billions or trillions of parameters, meaning there's nodes and weights between all of those nodes. It starts off randomly, and this was really the breakthrough in AI that sort of helped us through the late 1990s and early 2000s, which was something called backpropagation, which was you can give the network a signal, like here's an input, and I'm expecting a certain output. AI, by the way, and ChatGPT and all the others are no different. AI, deep learning networks or transformer networks turn every problem into a probability. That's one of the key things, right? It's where the sort of randomness comes up. But what happens is you start off in a random state, and then you essentially encourage, in kind of an evolutionary way, the network to come up with the right kind of answer. That's why it's very important to have very sort of clean data and a good understanding of how the network works. I think there's going to be a huge amount of research. I know DARPA's investing a lot in that, trying to understand like what does this black box actually do? Where is knowledge actually stored? So anyway, obviously I could talk a lot about that stuff, but it's a really fascinating question, and I think in a way it is kind of evolutionary. We have played with using multiple models to come up with better answers. So what we will do sometimes is say, okay, let's say you're using Anthropic here and you're using Llama 2 here, and then we'll use OpenAI to choose the best answer. So sometimes we do that. And that's also an interesting approach for a different layer of security. So if someone's trying to hack your model, you assume that every prompt that someone puts into the system is a poisoned arrow of some sort. And so that you add a layer of LLM above it. So, there's a lot to go in there, but.
We're at time.
We're at time,
already.
yeah. So
like
I guess
I said,
we have time for one
talk
question.
too much. But come find us after if you have any questions, or if you can find someone else if you have questions about where to go next, because I can't help with that myself.
That was great. Thanks, guys.
Thank you all for coming.